Hey y'all, in my absence, I have created some videos of what we went over in class to help you keep up and see if you have any questions. So this first factoring video is going to be when A is specifically 1. We'll talk about some GCFs, but all of our factoring will have A is equal to 1. I'll do another video in which A is not 1, and you'll see those differences. On page 2 in your packet, I included a little factoring quadratics graphic organizer that you can kind of go through. You can see if you have to start with an x squared term. If there's not an x squared term, then it's either not factorable or it's already factored. If there is an x squared term, then you should always look for a GCF first. If you have a GCF, you should take it out and then proceed as normal. Do ask yourself, do I still have an x squared term when you factor out your GCF? Because sometimes that GCF is going to make it a factored form. So if you run out of x squared terms, then it's factored. If you don't, then you just factor the trinomial just like you would have if there was no GCF. And we'll use the box method is what I use. And this is just a way to help us graphically organize what we are doing and so we can visualize it. So we'll start with an X puzzle and then we'll make a box. And I'm going to walk you through that later on in the video. Once you've done that, then it's factored. I do want to talk about the signs. So remember when we were multiplying binomials, so 5x plus 4 times x plus 3, then I'm going to do the x times the x, which is x squared, and then the x times the 3, which is the 3x. And I'm going to do 4 times x, which is 4x, and 4 times 3, which is 12. And then our final answer combines these two guys, so I get x squared plus 3x plus 7x plus 12. This value is my C value. This value is my B value. So if you remember, the C value was made from multiplying 4 times 3. So positive 4 times positive 3. And that's why the C factors will tell you if you should have the same signs or if you should have different signs. If C is positive, then you've multiplied to get a positive number. So your signs should be the same. And you will add those factors. Either both of them will be positive or both of them will be negative, because a positive times a positive is a positive, and a negative times a negative is a positive. When you multiply them, if you come out with a negative C, then you need to subtract your factors. And to get a negative, when you multiply, they need to be different. So your factors will have signs that are different. What those signs would be is based off of your B value. So if you remember, the middle two terms were what created the B value, and they were created by adding. So if B is positive and C is positive, then both of your signs will be positive. So when you have a positive C, the B value tells you the signs of your factors. If C is negative, then your signs need to be different, and the B value tells you which one gets the negative. So the B value will go with the sign of the B will go with the largest factor. So take a look at example number 2. So you always want to think this is A, this is B, this is C, this is a 1. I'm going to make my X puzzle. On the top, I always put A times C, and on the bottom, I put B. I want to multiply to be the top and add to be the bottom. So A times C would be 1 times 5, which is 5. And then my B is 6, so I'd have positive 6. So I want to think to myself, what are the numbers that multiply to be 5 and add to be 6? Well, 5 is prime, so it only has one option, and that would be 5 and 1. Since my 5 is positive and my 6 is positive, both of those need to be positive. You can make a box for this one. These are the ones that I won't require a box for because you don't technically need it. So remember, in the box, you start with your A value, the C value goes at the bottom, and then the diagonal comes from these numbers. So I'm going to have plus 5D and plus 1D. I always put a sign there so that I know. Then I'm going to get the outside numbers by seeing what will multiply to give me the inside numbers. So I know that D times D is D squared. And then D times what is 5D, and then D times what is 1D. So I know that D times positive 5 will give me positive 5D, and D times positive 1 would give me my positive 1D. And then 1 times 5 gives me my positive 5. So my factors come from the outside of my box. D plus 1 times D plus 5. When A is 1, it will always be whatever the factors were from here. So if a is 1, you don't need a box because the factors come out of the x puzzle. Looking at number 3, now we have 2 terms. We have an a term and we have a c term. B is gone. So that means when we make our x puzzle, at the top we're going to do a times c, which is 1 times negative 144, which is negative 144. And then at the bottom I need to put b. Well, there is no b, so that's 0. Because 0 would times x would be gone. Then I need to think to myself, what will multiply to be negative 144 and add to be 0? And that would be negative 12 and positive 12. If you don't know what the factors are, you could always come over here and make a list of all of the factors of 144. So you'd start with 1 and 144, 2 times 72, 3 times 48, 4 times 36, 5 doesn't work, 6 times 24, 7 doesn't work, 8 will work, it'll be 8 times 18, 9 won't work, 10 won't work, 11 won't work, and then you get 12 times 12. If you do them in order starting at 1, once you get to a repeating number, you know that you are done, and then you can mess around with the numbers and use the signs to help you figure out which ones work. Since my a is 1, I am not going to make a box for this one. I'm just going to go straight to y minus 12 times y plus 12. And that would be my answer, because y times y is y squared. Y times 12 would be 12y. Negative 12 times y would be negative 12y, which would make 0. And negative 12 times 12 would be negative 144. The next one I want to look at is number 5. The first thing you want to do whenever your a is not 1 is you want to look and see, do I have a GCF? So will 3 go evenly into 3, 15, and 42? I always start with the a value because that's the smallest usually, but I would start with the smallest number and see if that's a GCF. 3 goes into 15 5 times, and 3 goes into 42 14 times, so that means that 3 is my GCF. So I know I have a GCF of 3, so I'm going to divide all of them by 3. There's not a G in all 3, so I can't take a G out. So I write my GCF out in the front, and then I'm left with 3 divided by 3 is G squared, minus 15G divided by 3 is 5G, and 42 divided by 3 is negative 14. Once I've done that, I'm going to factor just the inside of my parentheses the same way I did in those last couple of equations or examples. So I'm going to make my x. At the top, I'm going to put negative 14 because 1 times negative 14 is negative 14. And I'm going to put negative 5 at the bottom. Then I'm going to think to myself, what will multiply to be negative 14 and add to be negative 5? Since my c value is negative, I know my signs need to be different. So I can go ahead and put a negative and a positive. And then I know that 7 times 2 is 14, and that if I subtract 2 from 7, I get 5. But I want a negative 5. So that means my 7 needs to be negative because it's bigger, and my 2 needs to be positive. So then negative 7 plus 2 gives me my negative 5. Again, my a was 1, so I don't need a box, but I do need to make sure I keep my GCF. So the 3 needs to stay out front. So then you have G minus 7 times G plus 2. Because remember, you want this answer to multiply back to give you the original problem. So that's why that 3 needs to be there, so that it multiplies into whatever you get from G minus 7 times G plus 2 to give you your 3G squared minus 15G minus 42. All right, so I hope that helps you with the factoring when a is 1. I'm going to do another video where a is not 1 and do a few more problems, and hopefully that will be enough practice to help you.